Hey everyone, Lucas here again. We're diving into the urinary or renal system, and we're going to talk about the kidney today. So first I want us to look at the upcoming module and dive into what week 10 and week 11 look like as you head into the end of this quarter. So it's been a wonderful quarter. I hope you've enjoyed the class. I know that there's always little things here and there that can get better, and that's something that I'm continually going to be paying attention to make sure that we are doing the best we can to make our courses highly effective and enhance your learning and your support. So if you have any feedback on that, always got an open ear and willing to listen to what works and what doesn't work for you, even though that may not be the same for everyone. It's always good to hear and make changes. I think as a leader, as a teacher, you have to be willing to listen to what people have to say and use that to inform your decision making. Now, that doesn't mean I'm always going to use what everybody says, because sometimes there are reasons we do things, but I definitely would love to hear anything you have to say. And I'd also love to have, if you want to check in with me on Zoom or shoot me an email, let me know how you're doing. Please do, as we head in the last couple of weeks. I want to make sure you're surviving and making sure you're on the right path to being really successful the last couple of weeks in this course, so that you get the best grade you can as you head into your next biology classes and into nursing school or whatever type of allied health, whether it's dental hygiene or radiology or physical therapy that you might be heading into. I want you to make sure you're set up for success. So please feel free to reach out to me. All right, week 10 for this quarter. Could be different in different quarters, but we're diving into the urinary system. First thing on the module here is that study guide. Make sure you're using that as you work through this module. Read chapter 25. Again, use that study guide as you read and chunk it out. Don't try to sit down and read chapter 25 all in one night. I've extended the deadline for these assignments till early next week, like Monday and Tuesday, because you have Thanksgiving this Thursday. So however you celebrate Thanksgiving, please enjoy or if you, whether you celebrate it or not, just enjoy the time this weekend with your family or those who you consider your family, and those who you're around. If you're isolating and not being around other people, connect with someone somehow. Don't isolate yourself so much that you're not connecting in some way, shape, or form to people. We are, whether we like to or not, we need people. So, and if that means you got to shoot me an email or something, please feel free to do so. I don't want anybody being isolated and alone during these times. So I would love to hear from you. If you need help in any way, shape, or form, please reach out. I'm glad to do so. Now, after you read chapter 25, dive into case study team discussion number 5. That's the next thing you want to begin to look at. You may not have a perfect answer right away this week, but at least get in there and read what's going on in this last case study team discussion, because this will be your last one as we head towards the end of the quarter. I have some videos in here for you to watch, and then your first activity is going to be the kidney anatomy lab activity. We're going to look at the different structures of the kidney, and we're going to talk about those in a minute with this model I have in front of me that I'll be holding up. And then you have the kidney anatomy lab activity self-evaluation quiz, so make sure you're taking that. I have a few diagrams on there that I've made or I've manipulated that I want you to look at, that have to do with how we produce urine and reabsorb nutrients in our kidneys. So the RAAS pathway diagram is the renin, angiotensin, aldosterone pathway. And what that is it looks at how we control blood volume and blood pressure. And part of that has to do with vasoconstriction and manipulation of enzymes in order to produce vasoconstriction or reabsorb water and salt, and in an effort to maintain blood volume and blood pressure. So that's a very important pathway, okay? And it involves more than the kidneys, okay? Renin and angiotensin are not just kidney specific, okay? The liver and the lungs are highly important to the renin, angiotensin, aldosterone pathway. And aldosterone specifically acts on the tubules in the kidney to reabsorb sodium and water, which goes right back into the blood and helps maintain that blood volume. And renin and angiotensin act more as vasoconstrictors on different blood vessels. Okay, so make sure you pay attention to that pathway and understand how renin is made or released, I should say, and stimulates angiotensin. And angiotensin 1 has to be converted into angiotensin 2. So those are all things you're going to have to look at, and that diagram clearly labels it out. I'm not going to go through it all right now because you'll start panicking, taking down notes. And I just want you to listen right now. The other diagram specifically looks at reabsorption and secretion in the kidney, in the nephrons, which I'll show you in a minute what those are. So it talks about how we secrete certain nutrients or ions, etc., into our urine production, and which ones we reabsorb back into our blood. Okay, and that's what the kidney is doing. Our kidney is maintaining balance in our body by reabsorbing certain nutrients based on what our body tells it to do, or the concentration of the filtrate, which is the fluid moving through the kidney, and then it secretes things based on that as well. Okay, and if you think back to like cell biology, there are specific types of transporters along a kidney, which I'll talk about, or along the tubules inside of a kidney, that dictate what moves through and how it moves through. There's co-transports where two ions are moving together in a certain direction. There's antiports where they're moving in the opposite direction, like a sodium-potassium pump. So there's different ions moving in and out depending on what the filtrate is made up of and what the blood is made up of. Okay, and that dictates how things get moved. If our blood volume's low, we're going to be increasing sodium and water retention in our kidney to increase our blood volume. And so if you think back to like Jane and her blood loss and what the kidneys are doing, the kidney's trying to retain as much blood volume as it can, and it does that by reabsorbing sodium and water. Okay, and we can also dictate how much fluid goes into the kidney by constricting our blood vessels in the glomerulus. Okay, and the glomerulus is an area, which I'll show you in a minute, where blood flow goes. And so we can actually constrict our arterioles coming in, the afferent arterioles coming in, and in order to dictate how much blood gets pushed in there at what pressure, and depending on pressure dictates how much filtrate gets pushed out. Okay, so there's a lot of things going on in the kidney that you're going to be diving into this week, and you want to make sure you're paying attention to those two diagrams. The next, you have a kidney filtration lab activity, so you're going to use those diagrams, use the lectures, use the book to work through the actual process of how the fluid goes in the kidney, gets filtered out, what becomes urine and what doesn't. And then you have some optional worksheets in here on the nephron, which might be helpful, and an answer key. And then you have a Lapster simulation as well. And again, most of these things have been pushed to early next week due date. One, because we'll be continuing with the renal system, specifically looking at more acid-base balance next week. And two, I want you to have time on Thursday to either spend time with family on Thanksgiving, or if you don't celebrate Thanksgiving, to just spend time relaxing and resetting your mind in whatever way you choose so. Okay, if you want to get these done earlier, today's Tuesday, if you want to get them done by Wednesday or Thursday, then that's fine. Feel free to. I just want to make sure you have the flexibility this week to not feel like you have to work on Thursday night on homework. Many people already have to do a job on Thanksgiving, so I want to make sure you have that flexibility to spend time with family or friends or people if you need that time. Okay, so that's week 10, looking at the urinary/renal system. Again, it's a highly important process that's not just about urine production, but about blood pressure and blood volume maintenance and acid-base balance in our blood. So it's very important for maintaining homeostasis in our body and allowing our body to perform normal functions. We need to be able to have the nutrients in our blood to maintain normal functions. And depending on what's in our blood and what we eat and how our body processes that can dictate how our kidney responds, if that makes sense. So let's dive into this wonderful model of a kidney here. So on one side we have the full kidney, and hopefully you can see that well. Okay, and you'll see you have the blood vessels come right here. You have the arteries coming in and the veins coming out. Okay, you have your ureter coming down. So this is all collecting in here and then goes to your bladder. So this is where the urine goes out the ureter to the bladder, okay? And then up in here you have collecting ducts where all the filtrate filters down to become or considered urine. Up in here, okay, in your renal medulla and your renal cortex, okay, you have where the pyramids are in the cortex layer out here, you have what we call nephrons, okay? And these nephrons, it's harder to see over here, start with something like this, and this is what we call the glomerulus, okay? And the glomerulus is a capsule, and they call the actual capsule around it, so these cells around it is the Bowman's capsule, okay? And it actually contains these blood vessels that come in. And so what happens is you have these arteries or arterioles coming into the glomerulus, and they come in with pressure, right? Arteries have pressure. So the blood comes in and pushes, all right, pushes the filtrate out of the blood vessels, because arterioles have thin cellular layers, right? It's not like they have stacks and stacks of cell layers on the blood vessel. So these really thin cell walls, and they have these filtration slits in them that allow fluid to move out of the blood vessels into the capsular space, okay? So fluid actually comes out of them into this capsular space, okay? And when it does that, it then works its way into the tubules, okay? And that's where we go through filtration and reabsorption process, okay? Now, only certain things are able to get out of blood vessels, like, you know, most of your sugars and proteins aren't going to be able to get out of your blood vessel easily for the most part, unless you have excessive sugar. And so generally it's just your water and ions for the main part that are being dealt with in this process. Okay, so but there are pressures that dictate that. So we have the pressure of the blood coming in, okay, but we also have the pressure of what's in the fluid. Okay, so we have these osmotic pressures. So you have osmotic pressures in the blood. So let's say we have a bunch of protein in our blood. Okay, it's going to be actually drawing water out of the capsule back in. Like if our blood's highly concentrated, it's going to draw water out of the capsule back in. Okay, and vice versa. So we generally have net pressures. Okay, and when you look through some of the urinary stuff, you'll see this. We have net filtration pressure that generally pushes things into the tubules. Based on what's in our blood, that gets adjusted, right? If we are losing blood, we're going to be tightening that down and restricting the amount of blood that's going into our corpuscle or into these glomerulus and into the kidney. We're going to restrict blood to the kidney to restrict blood here, so we're not getting a bunch of filtrate. We don't want to lose fluid, okay? And then whatever we do get in, we're going to increase the reabsorption of stuff so that we can maintain everything in our blood. Okay, if we're dehydrated or if we're losing blood or stress, we're going to do all of those things. All right, and so there are specific pressures which you're going to go through in the lectures and the work I have that talks about the glomerular filtration pressure. Okay, the pressure rate. All right, and what's in the blood, the amount of blood coming in, and what's in the capsule around it, in the fluid, the capsular space. Okay, dictates the pressures with which the water and the ions move. Okay, this right here is a full picture of nephrons. Okay, and so you can see the actual loop of Henle here of a nephron loop into the collecting duct. So each of these yellow things is a glomerulus, and they have nephrons that come off of them. And this tubule is where all of the reabsorption and secretion takes place. Now the loop of Henle is interesting because one side's permeable to water and one side's permeable to sodium only. And based on the way the fluid of the blood runs, it dictates how those things get reabsorbed. And I think as you watch the videos, that'll make more sense. But it's called a counter current exchange. So as fluid is running this way in the tubules, blood's actually running the opposite direction. So the stuff on this side of the loop actually gets reabsorbed into the blood before this side. And so the way this gets reabsorbed dictates the way this gets reabsorbed. And that'll make more sense when you watch a video up close. But there's a lot going on in these kidneys. Okay, They're highly important to maintaining blood pressure, blood volume, and urine production, as well as acid-base balance. When we get into week 11, you're going to dive more into the acid-base balance. Okay, make sure you watch the Khan Academy and Crash Course videos. Reach out to me if you need more help. I think a lot of the activities I provide in this help people understand the filtration process. There's a lot of medications that approach these systems. For example, ACE inhibitors. ACE inhibitors are part of blood pressure maintenance. ACE is an enzyme that converts angiotensin 1 to angiotensin 2. Angiotensin 2 is a vasoconstrictor that increases blood pressure. So there are things that you're going to deal with in healthcare that impact these systems that you're going to want to pay attention to. Okay, and aldosterone is a hormone we talked about all the way back in the endocrine system. You're also going to hear about the antidiuretic hormone again, ADH, which is a huge part of this process, but is inhibited by alcohol. So there's a lot of things you're going to start to connect from previous modules this quarter. And I think when you do the end of module assessment here in a couple weeks, you're going to see how everything starts to come together. There's a lot of things that connect when we start talking about the renal system and the balances that have to be made in the body using the kidneys. Okay, which is why when people have kidney failure, their bodies shut down really quickly, and it's not a good situation. All right, hopefully this was helpful. Dive into this week's information, but make sure you take time on Thursday or Friday, whenever you're doing something with family or resting, to take that time to just not have schoolwork and do what you got to do. If you're working, take another day and please take the time for yourself and for your family and your friends, because it's an important part of our life, especially now with how isolated things are. So take care, reach out to me as needed, and I hope you have a wonderful week.